using the different mixing technique, of course, they clearly have a significant difference. But the only thing is we do not know which pair of them they are significant different. Is it the 1 and the 2, or 1, 3, 1, 4, or 2, 3, 2, 4, or 3, 4? We do not know which pair of them. So we need to further analysis instead of the testing for overall. So for the first part, the analysis variant table is testing for overall. We know that using the different mixing technique will produce us the different results, okay, or give us the different strength, then tensor strength. Okay, so this one will be answer your question number A here. Okay, after that, for the question number B here, you compare the mean tensor strength for the 4 mixing techniques. What are the conclusions you can make? Okay, so of course here is they using is a plot, but I have removed the plot here. Okay, so if I want to testing for the here, before I testing here, okay, yeah, I will tell you this one first. Then if I compare the means, as you observe that the smallest mean is the mixing technique number 4, and then followed by 3, 1, and 2. So these are the mean here. Then I can be, instead of using the graph, testing using the LSD. Okay, Lsd formula you also can be see from the chapter number 3 here. So the LSE is equal to T distribution multiplied by square root of the 2 times the MSE divided by N. Okay, so the T value here, is actually from the T table. Okay, the T table, the statistical table, the T table will be here. Okay, the T value table. Okay, if you don't have the table, then of course you can call out the R using the codes to get the critical value for the T given the alpha here. Okay, so under the T table is a T distribution table here. So this value is called the T value, is a 2.179. So if you refer to the T value here, of course you need to know the degree of freedom. I may put it here first. Okay, I may put it here in case you forget about it. The T value here, the T value, they may refer to the T value here. They need the degree of freedom as well as the alpha over 2. Okay, so the T value 2.179, in fact, I get it from the, let me see the degree of freedom for the error is a 12. Okay, the value is actually I get it from the T with the degree of freedom 12, because the degree of freedom refer to the degree of freedom for error, so it's a 12. Okay, let me see the table here. I refer to the degree of freedom number 12 here. Okay, is this value. So I set the alpha as a 5%. So therefore I refer to the alpha 0.025. So in this case, because the LSD, I put the modulus, they can be larger, can be smaller. So they are testing for the 2 sides. So I need to have an alpha. Alpha is my type 1 error. I set it initially from the question itself. I set it initially is a 5%. So therefore, the alpha or 2 is 0.025. So refer to degree of freedom 12 and the alpha here. The 0.025 and the 12, I will get 2.179. Okay, so therefore, I can calculate my LSD is given by the T times the square root of the 2 times LSE divided by N. So I get 174.5. So after that, I get the difference for each pair, the difference in their means. So the mean for the 2 minus the mean for the 1, I will get 185. So which one were larger than the 174 is considered as a significant difference. So therefore, from here, you can see that only the pair number 1 and 3 is no different. The 1 and 3 is no different. All the pair 4 and the 3, 4 and 1, 1 and 2, all they have a significant difference. Okay, only one particular pair. If let's say you want to use a mixing technique number 3 or mixing technique number 1, you will produce a similar result based on the analysis here. The rest of them, if you use a 4, of course, it's different from the 3. If you use a 4, different from 1, or 2 is different from 1, and so on. Okay, only one pair of them is no different. Okay, it's a 1 and the 3. Okay. So this one is how I calculate. Yeah, of course, the software here, they just tell you the answer. Okay, 1 and 3 are the same. 4 and 1 and the 3, they are different. 2 is different from 1 and 3, and then the 2 and the 4 are different. Okay, so this one is consistent with my result here. Only one pair of them, they are the same. Okay.
Sorry, Doctor.
Yeah.
For this question, can we use the turkey test to do?
You can do it. You can use a turkey test to do it. Because I don't use a turkey is because before that I don't give you the table of the turkey. The turkey one, they use a special the value is no more t distribution. It's a q. It's a q value. If you use the turkey one, you need to refer to the q value. This q value may not be available in the R. So therefore, you of course, yeah, they based on the Q here. You can refer to the notes of the chapter number 3. Yeah, you use the LCD, you based on the T. You based on the T, but you based on the turkey one, you need to know what is a Q. If you use, are you using the turkey one?
Yeah, I was using the turkey.
Yeah, then you have this Q value or not? If you have Q, then you can go ahead. If you don't have the Q here, the Q is get from this table. The standardized ratio. It's not the T value. It's from the Q. Okay. Yeah. Yeah. If I do not specify any techniques, you can be use any technique. But most of the time, I will need to specify. I need to specify certain technique. If I don't specify the techniques, the vary. Sometimes you can be used other than the what I taught you, the 2 techniques, because you can run from the software, then you get the results. Then after that, I cannot be do the checking. So therefore, I will try to fix it for the certain techniques. Okay.
Professor, I had a question.
Yeah.
Hello. So hi. So the Minitab output. So yeah, when I use R and I use the turkey test, I get a different.
Correct. They are different. They're different one. Yeah. Sometimes because in the software itself, we do not know how they do it. Sometimes they use an iteration. They use an interpolation. For example, you can see from this table also. Sometimes we cannot be get exactly what the value they fall in between here, or certain value where you cannot find. Like for example, in this table, I only give you the 0.01 and 0.05, the Q. Okay, other than that is no more. Okay, if you have textbook, you also can get this table. How about if I want to test at the 0.02%? So the software, they may use the iteration. They may use the interpolation techniques. Therefore, we do not know unless we go to check it carefully. What are the formula they use?
Because for me, the first one, the first pair, is not significant.
Which test? You refer to which answer first?
Okay. Can you go back to the table? The Minitab, the Minitab. Yeah. So you see that the one versus 2. The t value they put there minus 2.31. So that's a significant difference, right? So for me on R, it's not significant. It's quite high. The p value is 0.15.
No, this one is they significant.
Yeah, but when I use R, I'm getting a very different p value.
Is it you get negative 2.31?
I get positive 2.31.
Okay, it's fine. But when you get your p value, how come you get the different? I believe that you may do the wrong thing. Okay. If you get the what is the value you get for the p-value? You let me know.
0.1493.
0.1493 based on this value 2.31.
Yeah, I'm just using this Tukey test in R. I'm not doing anything manually.
Yes, but you using the let me see because you see the result here they based on is using the t the t distribution. So if you get the negative 2.31 based on the t distribution, you can see I calculate from the Excel 2.31. Okay, the value for the t is 2.31. I believe that Excel will have this thing. So I just go to the t distribution. Yeah, t distribution, the t distribution. Okay, the t distribution, I key in the value of the x is here, and then followed by degree of freedom. In this case, just now the degree of freedom is 12. Okay, then I will give the true. True is stand for the cumulative. Okay. So if you do this thing, this one will give you on the left hand side. Let me check it out. Okay, 2.31. So I need to use a 1 minus. You get is 0.0192. This one is what you have. Is it you get this value?
No, the value is 0.14. Yeah, 1493. Yeah. So yeah, when I do the t-test when I manually try to find through the CDF in R and I use the t distribution, I get the same as you, the 0.0197. So I don't know why
Therefore, unless we know what is the reason behind the formula used.
Yeah.
Okay, because R is, I think that this type of the program is written by somebody. They may use a slightly different formula. Because unless we know the codes, what the formula is, because they program it inside. Even though if you use a Minitab, also you can get the slightly different answer. Yeah. Okay, it's because of I think that is because of when they do the interpolation, the result may not be adequate, so they try to approximate. But I will think that the answer is definitely the correct one. Because otherwise they won't be show to the public this are the answer. The only thing is maybe they have some rounding or they have modified in their formula.
Okay. Yeah. Sorry, follow-up question. So they're using the t statistic, right? Yeah. So that's what I realized. Like if you derive it, it's a t statistic. It's I don't understand why it's studentized, because it's just the you know what I mean, like
you say
I get a t statistic.
But you see therefore this one is I give you the whole result here. I won't be use their result unless I know what happened, because even though here is a call over the t, but is it they are based on the t, the test statistic they have. Even though you can see just now I get 2.31, but here I get this thing. The probability is quite different.
Yeah.
Okay.
Yeah.
So for me, I will suggest you all will be use the whatever I given you to you in the manual here. Then if let's say, because there are too many software to do the calculation, I also don't know whether what type of formula they use for the approximation. Yeah.
Yeah, I was just saying that
yeah.
You said that the Tukey test uses the studentized range statistic. But if you like follow the instruction.
Which instruction is it?
Like it's not actually y max minus y min, right? It's just y bar of level
y
1.
Max, yeah. They use a max.
Minus. Are they really using max? How do you interpret that? How do you use the max?
The max one, because they compare is a max one is a maximum value of the mean minus the minimum. So because you only have you compare for the 2 one, of course, it's just J and the I only.
Yeah.
They want to make sure that they must be positive. Therefore, they use a maximum. I don't know which one is maximum. They use one of the positive larger minus the smaller.
Yeah. Yeah, because it looks to me like they used y bar 1 minus y bar 2.
Yeah, so but provided that y bar 1 must be larger than the y bar 2.
Yeah. So in which case, wouldn't it just be a t statistic?
I believe that they have similar to the t statistic, except they do some adjustment. Because I think that I do not know why they have because I'm not going to start. I'm not studying about the Tukey, these techniques. Okay, I think that they are similar to the t distribution, but because they want to get more accurate thing, then they have suggest about the t value here. We can be referred to this table. Okay, we refer to this table. You can see that this thing is because they depends on the P and as well as the F here. So therefore, I think that they have do the adjustment here. They do an adjustment of this test. They can be go to the T under the certain condition here. They can equal to the similar to the T.
Right. Okay. Okay.
Yeah. Oh.
Okay, thank you.
But you ask me why the Q here. In fact, I never go to study what is happening with the distribution for this procedure. Therefore, I will just accept it only. Okay.
Okay, thanks.
Yeah. So yeah, this one is what I have here. Okay, for the here. Okay. And then this one is a LSD result. Okay, the LSD result is similar to I have shown it to you here, the LSD result here. Okay, then I think that I go back to the just now I just go back to the first question. Okay, for the test of the hypothesis ANOVA, then you can see my solution here. I give you more than that. The first thing is I will give you how to produce the ANOVA table values. So make sure that you know about the hypothesis. If you are testing the mean, of course, your mean can be the 1, 2, 3, 4, 5. You have testing the mean here. And then the H1, you are written as at least one pair of the mean I not equal to mean J. Okay. Similarly, if you want to write it as a tau, so you have a tau 1 until the tau 4 is equal to 0. And then the H1, at least one of the tau is, not greater than, it should be not equal to 0. Okay. This one, I will edit it. This one, it should be not equal to 0, not greater than 0. It's not equal to 0. Okay. And then here is how we want to decide whether it's a reject or do not reject. If you base value of the 12.73, you get it from the F value. If from the table, you get your value is 3.43. So you fall in the rejection region. Therefore, reject the null hypothesis. And then you can make the conclusion, say that there is enough evidence to conclude that missing technique affects the strength of the cement. So this one is what you have it. Okay. Okay. So you have it in the following one. Okay. If you use a manual, but of course, if you use a software, then you directly will refer to the p-value. Okay, you need to know how to get the information. You refer to a p-value. After that, you compare with the alpha. So from here, clearly, you can see that your p-value is smaller than alpha. So this one, it will say that you are reject the null hypothesis. Okay, it's similar to what I can do it manually. Okay. And then here, the following question will be the following part. What you have here is construct the normal probability plot of the residue. So in this one, like this type of the plots, for the tutorial, maybe I will show it to you. You can use the software to do it. If you do not have a software, then you just looking at the answer here only, because I don't expect you to do the manual doing calculation or the drawing the plot of here. Okay, even though the exam I also never will ask you to do this type of the plot on hand, unless this one is an assignment that is possible. Okay, so you can see that for the all the tutorial question, you have the normal probability plot, the constant variance, checking for the constant variance independent. So that one is just give you the guideline only. Okay, the important thing is still about your formula. Okay, because I will deal with all the mathematical works when you're testing you for the exam. So you need to know, okay, for this question, the residue is behave in the following form. Okay, so you can see that you cancel out the mu, so your residue will be equal to Yij minus the just a Yij minus away. These two can cancel off. You just get the mean of the I. Okay, so this one is here for the residue. Okay, I think just now I have a repeat for many times. Okay, so this one is for the first question. Okay.
Sorry, doctor.
Yeah, anything?
These plots, right? Is it possible to draw it manually, or you need some kind of software to help to draw?
If you have a like you can see from here, if you have a mini tab, definitely you can draw it easily. Just one time, you just one button click, as long as key in the data, you already can come out all the plot directly. Okay, but if you want to draw it the plot, you can use the codes I given you in the R, in the R here. Let me see where is the code. Not this one. I think not this one. I should be referred to this one, your solution one. Yeah. You just use the code here. Yeah, the code is not this one. After you first thing you need to run your ANOVA. This one is summary. No. First thing, if you want to run your output, first thing you have a data. Where is the source of the data? After you get the data, you run the ANOVA. Then you put the summary of the ANOVA. One-way ANOVA. You call it as a one-way ANOVA. Then you already can get your ANOVA table. So after that, you just use a command say plot. I give you here. Oh, I don't give it to you. I don't give it to you the line here. I will okay. The line is maybe is a plot. The name is called the plot only. Let me check. No, just a plot. You just plot the one way, then you already can come out the result. Because once you run this ANOVA, you already call the ANOVA table, so they already can calculate for you the residue. Then once you click the plot, you can come out all the results here. Just now where is it? Now all this plot will come out.
Oh, okay.
But I think that you just know the idea only. You no need to go to plot it, because you plotting, you need the wasted take the long time to plot, do the plotting. Okay.
Okay. Thank you.
Okay. So this one is basically is about the question number 1. Okay. You also can have a different question on the second question. In your second question, what I give it to you is a similar. Is it 2 point? Let me see. The first question is a 7. The second one is for the 19. For the question on 19, as you can see out, the answer will be the question will be quite similar. Okay, they just ask you whether there is a difference in between the coding type. So you just perform the analysis of variance table. Okay, from the analysis variance here, clearly we can refer to the p-value here. The p-value shows us that there is a significant difference. Okay. After that, we can check out if we want to know which pair of them have a significant difference. Then we are looking at the results. Okay. So from the here, if you use this software, of course, we can clearly see that this one, this one, this one, and this one. This pair, this. Okay. These are the results. They are significant different. Of course, I need to compare with a certain alpha level. Okay. So the alpha level I compare to, most of the time we will use just a 5% of the error to compare. So if you set the alpha is 5%, even though we set it as the alpha is a 1%, so you can see that this one is clearly smaller than the alpha. So this one will lead you to reject the null hypothesis. Only the 1 and the 2, 3 and 4 is no significant difference because you can see the p-value is quite large, the value. Okay. And then over here, for the part B, you need to know if I ask you to estimate the overall mean, you know that this is an estimation of overall mean by using the overall mean to estimate the mu hat. Then if I ask you to estimate your treatment effect, then you know that the treatment effect will equal to the mean for the first one minus the overall mean. Okay. And then, of course, here is constructing the confidence interval for the single coating fall only. So if you want to, the confidence interval for only one particular of them, then we can use just the 4 dot plus or minus the t value multiplied by square root of the MSE divided by sample size. Okay, in fact, here is a sigma hat. So, but because our estimation is using the MSE to estimate your sigma hat, okay, you sigma hat square. So you square root of MSE divided n. So this one will be the confidence interval for this part. So if you are looking at the difference of the two means, then this one will be equal to the 1 and the 4. So you have a 1 dot minus the 4 dot. The t value, then followed by the square root of because you have a variance here and here. So suppose you have a MSE over n plus the MSE over n. So you total out these two, become the 2 times of the MSE divided n. Okay, in fact, they come from here first. Then you have a 2 times of the MSE divided n. Okay. So after that, you have a following one is testing the pairwise. I think I have show you the answer here. This answer I will upload it. Yeah, these are the things I have mentioned to you. Okay, so I have shown you the formula of the confidence interval for the difference in between two. I will write it down here. And then of course you want to compare for the pairwise. Here I just show you the final answer, which pair of them is the same or the different. So in fact, the explanation were here. First thing, I calculate the LSD. LSD is given by here. After that, I look for the difference, the absolute value of the difference, and then which pair of them is greater than LSD is considered there is only 1 and the 2 and the 3 and 4 no significant difference. So if you observe it, this thing is 1 and 2 is no different. And then the 3 and 4 also no different. The rest of them, they have a different. Okay. So this one is I just give you the summary of here. But if you want to work out the answer, you should need to work it out this way. Okay. Because sometimes certain work is R, you cannot get it. So in that case, you need to do it. You need to program yourself. If you wish to do it, you need to program yourself to calculate the values. Okay, so basically the chapter number 3 and the chapter number 4, this one is just the introduction part. Okay, Let me go to here. Okay. So about the following one is for the 2.2. For the example number 2.2, this data set is of course they get from the journals. These are the results. They run the experiments. They obtain it. They want to compare different diameter. They have a different effect on the gradient release. So this one is what they have, the results here. Of course, the result here again is show you that there are significant difference based on the p-value here. Okay, based on the p-value here, they consist of the significant difference, means that you're using the different diameter will give you the different results. So after that, we can compare the pairwise. We can plot the residue plot, find the p-value here. Okay, so before I go for the comparison of the pairwise, I may discuss about those of. I know that this time some student their background is not from the statistics. They may be from the engineering, from the economy, from the business. But I just want to remind you all the p-value, how you get it out. I have written it here for the question number 3.22. If you want to get the p-value, actually the p-value is the f value is greater than 30.82. How do I get 30.82 is from the test from the ANOVA table here. Okay, 30.82 here. I want to get the value is what is the p-value. Okay. So if you don't have any software, of course you just use the MS Excel. I use the 1 minus by f distribution 30.82 with their degree of freedom, and then the true is stand for the cumulative. They want to find the CDF, then you can get your probability is given by the using this software. If you're using other software, it's up to you. You can use the R to calculate what is the p-value, but you need to be careful. Some of the software they give you the answer is greater than. Some software they give you is less than. Therefore, you can see here I use a 1 minus the f value from here so that I get the answer is greater than. Okay, you need to familiar with that particular software. Okay. So this one is I want to say about the p-value, and then this one of course is a residual plot. Okay. The following one will be what I concentrate on is about the here is just a confidence interval for one particular section. Okay, so this one is for the question number chapter number 3. I just give you the exercises so that you familiar with the ANOVA. Then you can proceed with the chapter number 4 or 5. Just now we gone through is what the factorial analysis. The calculation will be quite similar. Okay. So besides the one-way ANOVA, I also give you some examples for the chapter number 4. Okay. For the chapter number 4, that one is using the blocking. And then after that, I also give you the one example for the Latin square. Okay. So I may discuss about this question first. So for the question of 4.8, we have a following here. We want to compare is the effect of 3 different replicating oil. We are comparing this oil, but because of when they do the measurement, 5 different truck engines are available for the study. So therefore, they're using the different engine. Then these 5 different engines, they may have a different performance. Therefore, there is a call, some sort they call as a blocking or the Nelson factors. Okay, Nelson factor will come in. Okay, so the Nelson factor is actually your trap. So in that case, you need to use a blocking techniques to remove away, or you need to extract out the blocking component. Okay, your main target is comparing the different oil. Okay. So in this case, the analysis variant will be still the same, except your model will be different. So in this case, I also have shown to you calculation of the sum or square for total treatment and the block. I have shown it to you here. Okay. The important thing is you know that this model will be equal to okay, you have a treatment, you have a blocking. Therefore, you have a sum of square for total, treatment, block, and the error. Okay, so the calculation or the formula of the sum of square for treatment, sum of square for block will be similar pattern. And then the sum of square for total will be applied for all the design using the same formula. Okay. And then of course the analysis variant here is quite standard, except here. Because from the analysis here, we found that from the analysis here, we are testing the factor A here. This one is show you that 0.0223. So this one will show you that there are significant difference. They're using the different oil. They're using the oil number 1, 2, number 3. There are significant difference in their mean. So we need to further analysis it. The further analysis will be deal with the like using the LSD, or you want to use a Tukey test also can. Okay, so here I show you the example. Okay, I have a 3 mean. The first mean is 0.49. The second mean 0.5. The third mean 0.41. So we calculate the LSD will given by this thing. Okay. Then we compare. We do the comparison of here. I found that the 2 and 3 there is a significant difference. 2 and 1 significant difference. 1 and the 3 no significant difference. So this one will lead you to the conclusion that if you're using the type number 1 or type number 3 is no significant difference. Okay. But if you use number 2, they of course they were different from the rest of them. Okay. So this type of the post hoc test is very important. You can go in which combination there is a different. If no different, then you can be interchanged to use it. Okay. And then over here, I also showed you that the residue formula were written as a foreign quant. Okay. Another thing is I also need to remind you is about the t value here. The t value here, the x here is actually the degree of freedom. So when we want to calculate the t value here, they depends on the degree of freedom. But what is the degree of freedom here? In the ANOVA table, you also have a degree of freedom. In the t value here, you also have a degree of freedom. So this degree of freedom actually is referred to a degree of freedom for the for MSE. You are referred to the degree of freedom for MSE, so it's 8. Okay, then you will get the degree of freedom 8 here. Okay, this degree of freedom is referred to degree of freedom for the MSE. Okay. So since your model you include the blocking in fact there, so your degree of freedom for MSE will be changed. Okay, depends on what is the model you have. So this one is should be the question for the blocking effect. Okay. Any of you have a question?
Yeah. How is the randomization done for this question?
Because if you want to run the which one you want to run for the randomization? Okay.
Yeah.
You let me open. Let me go back to the question. Yeah. When you want to rule the randomization, of course, you will get the truck. The truck here, they consist of the 3 observations. Before you have any measurement first, okay, before you have any measurement, you under the truck number 1, under the engine, okay, you have a different engine, okay. The first engine, you consist of the 3, you have 3 different engine under the first category. Agree? So the second category, you have a 3 engine. And the third category, you also have a 3 engine. Okay, before that, you have this thing. You don't have any data at all. You have the raw material or the engine only. You have engine 1, the engine number 1, you have engine number 2, you have engine number 3. So you do the randomization. You just put the 3 number here. You just do the selection. Which one will come first? If let's say I select is number 3, So the number 3, I will apply it to the first observation to run the first oil using the oil number 1. If I selected out is a number 2, then I will go for the second oil. If I selected the number, the last one is will be the last one is test under the oil number 3. Because here already give you the data, therefore they don't show you how they do the randomization. Even though they show it to you, because everybody run the randomization were different. For example, if I want to run it, maybe the second observation run first, then this one is run the first, this one will run the third. Or some of you may have a 1, 2, 3, or you have a 3, 2, 1. So you have a different type of the combination. So if you want to run the randomization, is make sure that before you have get the results, you assign your raw material or assign your raw material to the this combination. You make sure that you randomize it.
Okay.
Huh? Yeah.
Understand. Thank you.
So I only show you the result when I return one. I show you is only until here. Okay, I will show you. But of course, the Latin square, they will take the longer time where you need to calculate one by one the component. But I believe that the same techniques will apply. Okay, so you can try it out. So basically, this course is different from the other courses. Some courses is maybe more to the theory. But for this course, even though they consist of the theory, but their theory is not as tough as the other courses, because if you go through the different design, you can see that almost all the design will get the similar pattern. Okay, just the equation will change. Okay.
Sorry, Doctor?
Yeah.
Yeah, for the analyzing the residuals, right, does it mean that we have to have the plot in order to analyze it?
Correct.
Okay.
You need to have a plot. If you need to analyze that. But as I mentioned to you, okay, of course, now you can do the practice, you can use any software. But for your information, in the exam, I would be asked you to draw the plot.
Oh, okay.
I don't ask you to draw the plot to do it. Even though the residue analysis, you draw the plot. Instead of the plot, for example, the normal probability plot, this one is just a graphical view of the answer, but you still can use a goodness of fit to check whether they are really fitting the normal distribution by using the hypothesis testing.
Oh.
Okay. Then about the constant variant, you just looking at the plot for the fitted versus the residue. But instead of a plot, you also can use the test is called the Butler Test to checking for a few component of the variant.
Okay.
Yeah. Then about the independent, you want to look for the independent. Is it the pattern is random or no random? We can use a non-parametric test, the run test, to check whether they are independent, they are randomly. Their point is a random or not random. So not only the graphical thing, you still can support with your hypothesis testing techniques.
Okay.
Thank
you.
As I repeat again, for all the plots, normally I won't be not normally. So far, I never asked the student about going to plot the graph during the exam. Because if you plot the graph, you need to spend the time to find the graph paper to do the plotting. So therefore, I don't ask you, unless last time I give them is just ask them to do the assignment, then they use the software to produce. Okay. Any more question? Okay. So the tutorial one, I think is for me lah. I think it's just the warming up for your prepare for your ANOVA. Once you're familiar with the first tutorial, then you can proceed faster for the ANOVA section, and then the 2 power factorial design, you are more familiar with it. Okay. So for the tutorial 2, I will start with the factorial analysis. Okay, so I need to check it out because we only stop until the the factorial for the next week. So if we have the I will check the question first. If we can have enough question, then we have a tutorial for the next section. Otherwise, we may not have a tutorial for the every week. Okay, yeah. So any more question? Okay. If you have any more question, instead of the tutorial time, besides the tutorial time, you also can ask me. I also receive some, some students, they send me the message, private message also. You can be ask me using the private message if you're still not ready for your tutorial. Okay, not necessarily must be tutorial time, you only ask a question. Yeah. Okay. So if you do not have any question, I think that's all for our lecture class. Let me check. Close on.